Bismillahirrahmanirrahim. Today our class in chapter 2, 2.4 and 2.5, equilibrium and Lami's theorem. Okay, so our topic here is equilibrium bodies in a system of force. We're looking on three forces in equilibrium. Here is definition of equilibrium. Equilibrium is when three forces acting at a point that can be represented as a side of a triangle. Each force proportional to the sine of the angle between the other two forces. According to this law, if the three forces can be form a complete triangle, then a system is called in an equilibrium. A state of equilibrium is said to exist when two or more forces act upon a particle or upon a rigid body and motion does not take place. This means that if three forces acting at a point can be represented by the side of triangle and the forces all act in the same sense around the triangle, then these forces are in equilibrium. Look at this figure. We have three forces A, B, C that acting at a point, at one point here, in equilibrium. We can represent this force into triangle. So we bring this force A, for example, force A. We bring to the one side of A. Make sure magnitude or direction of A is same when we bring this force A to the triangle. We have same direction here, okay? Same direction. And then we bring force B here, so we continue this triangle from A, also same direction, B here, B, and then C. For C we continue B to A, also same direction for C in the north, so that we can represent these three forces to triangle. And look here, we continue B to C. We connect force B and C here. Actually we bring this force C at the other side here, so then we can find the angle alpha. C and B here is alpha. If we bring C, connect B to C here, then the angle connection B to C will be 180 minus alpha. Also connection force C and A here, we have bring force C at here, so that connection here between force C and force A is better. So if bring the force here, so angle between C and A here will be 180 minus beta. Also connection force A and B. Here we have bring force B to this side. So angle between AB is gamma. So then if we bring this force B to the other side here, so angle here will be 180 minus gamma. Here in the triangle will be 180 minus gamma. And then we can calculate the force of ABC by using sine rule and cosine rule. So here for sine rule, A over 100, or A over sine 100 minus alpha equal to B over sine 180 minus beta, and C over sine 180 minus gamma. Also, we can use cosine rule to find magnitude or angle for this triangle. Look at this example. We have three forces here: E, 7 Newton, 24 Newton, and we have angle 60 here. The system of force below is in equilibrium. Calculate the magnitude A and angle theta. Calculate the magnitude A and angle theta. So then we can represent these three forces to triangle. This one we connect 7 Newton, force for 7 Newton and 24 Newton. We connect as triangle here, and we connect force A here. Okay, force A we bring here, so we get a triangle. And then here is 60 degree. So the other side, if we transfer to triangle, so this angle is 120, and this angle is 180 minus theta. So the question wants us to find magnitude A, this one. So we can use cosine rule. Cosine rule is equal to 7 square plus 24 square minus 2 multiplied by 7 multiplied by 24 cos 120. So we get magnitude A is 28.16 Newton. And then we want to find angle theta. Angle theta here, we can use sine rule. 7 over sine 100 minus theta equal to 28.16 over sine 120, and then we get theta equal to 167.57 degree. Look at another example. The system of force below is in equilibrium. Calculate the magnitude A and angle theta. Here we have force A, force 12 Newton and 24 Newton, and angle 45 degree. And then we want to calculate magnitude A and angle theta. So we represent this force to triangle. Here, triangle. Looking here, we have force 12 Newton. Here, force 12 Newton, and then force 25 Newton. So we connect here, and force A we connect here, and then we want to find A, magnitude A, by using cosine rule. Calculate by using cosine rule. So angle here 135 degree, just now 45. So we get here by minus 180 minus 45, then we get 135 degree. So calculate by using cosine rule. Here we get A 34.54 Newton, and then theta, this theta also we can use cosine rule. So theta here is 180 minus theta. Okay, calculate, then we get theta equal to 165.77 degree. Next, we look at more than 3 forces in equilibrium. When it involves more than 3 forces which is in equilibrium, to solve it, we can resolve the force into 2 components. Since the system is equilibrium, the resultant force acting in any direction is 0. So if the system is in equilibrium, then for x component, or total force for fx will be equal to 0, and also total force for y component, or total force for fy will be equal to 0. Okay, look at this example. It shows 4 forces act on particle at 0 which is in equilibrium. Find R and S. So here we have 4 forces, 10 Newton, R, 7 Newton, and S act on particle O here, particle O is in equilibrium. Here question state that the forces is in equilibrium. So then we want to find R and S. Because the forces is in equilibrium, so we will setting total force for Fx will be equal to 0. So we find first total force for Fx, means find the total force at the x component. So first here we have 7 cos 30 for 7 Newton. For x component we will use formula r cos theta. So for force 7 Newton, we calculate 7 cos 30 degree here, plus and then we have force S here, so we calculate S cos theta, cos 60 degree, and then we have force 10 Newton here, minus 10, because 10 Newton here is in the negative value at x-axis, so that we minus 10. So calculate this one, we will get S, force S is 7.9 Newton. And then we solve for y-axis for x component, because the system just now state that force in equilibrium, so we setting total force Fy will be equal to 0. So first calculate Fy for force 7 Newton. This one 7 Newton. For x component, we will use formula F sin theta. So for the force 7 Newton here, we calculate 7 sin 30 degree, 7 sin 30 degree, plus R here, force R, minus S sin 60. For the force S here, is in the negative value at y-axis, so that we put negative value here, negative F sin 60 degree. Then we calculate R will be equal to 3.3 Newton. Okay, look at another example. They show 4 forces act on particle at 0 O, which is in equilibrium. Find F and theta. Okay, we have 4 force here, 60 Newton, F, 8 Newton, and 60 Newton. Okay, we want to find F and theta. So first we solve parallel to x-axis, find component of x-axis. First we setting total force Fx equal to 0, because our force here is in equilibrium. So find component of x, component of Fx. First we have function force here, F, function F cos theta. Component x, we use formula F cos theta. This one is component for force F cos theta, and then here component for 8 Newton with degree 60, so plus 8 cos 60 degree. This one 16 cos 30 degree. Force for 60 Newton. Force for 60 Newton here in the negative value at x-axis, so that we put negative 16 here. Negative 16 degree 30, so negative 16 cos theta. So here we have equation F cos theta equal to 9.86. We cannot solve this one, so we try to calculate for component at y-axis, and then we setting total force Fy equal to 0. So here first is force F sin theta. Here force F sin theta, we put negative it because force F here is in the negative value at y-axis, so we put negative. plus 16 is force 16 Newton here. Force 16 sine 30, force 16 Newton here, minus 16 because the force of 16 Newton is in the negative value in the y-axis, and then this one is sine 60, the force for 8 Newton, negative 8 because force of 8 Newton is in the negative value at the y-axis. So calculate this one, we get f sin theta equal to 1.707. So we solve these two equations by using simultaneous equation. We divide f sin theta over f cos theta. So we equate to 1.07 over 9.86. Calculate this one, we will get theta equal to 6.2 degree, and then we substitute this theta into function f sin theta here, so that we get force is 9.92 Newton. Okay, thank you.